Hi, hello, this is Jenny. So today's topic is digital electronics. So it's an interesting topic to study and to do research also. Digital electronics means we are going to pass the circuits in the motherboard. Okay, so this is one of the basic hardware thing, and in this motherboard, how they will made that circuits. Okay, so in our computer system we are going to store the data, as well as we are going to do some operations in digital electronics methods. Okay, so in this circuit we have see lots of operations. Okay, so mainly digital electronics we are going to perform three operations: and, or, not, and then XOR gate. Okay, so that circuits full and fully we are going to cover in this topic. So gates as well as circuits. Okay, so to do perform our calculations and then to store the data in the system. Okay, so if you see that motherboard, right now we are using microprocessor. Okay, but in the previous years, current year we are using fifth generation or sixth generation. Fifth generation means we are moving forward to the artificial intelligence. Okay, that is quantum processor. Okay, so in the previous year, when it will start means in 1930s and 40s. Okay, the computer, little by little they invent. Okay, so who is the owner of this computer system? We know Charles Babbage. Okay, so in the year 1930s and up to 1940, in between the gap they developed some system. Okay, so in this motherboard they used that tubes, vacuum tubes, and second generation they modulate transistors. Okay, second generation in which year they developed? 50, 40, 40 to 50. Okay, and 60 to 70s they developed or they modulate that transistor into integrated circuits. Okay, so integrated circuits means that motherboard circuits we are going to pass the circuits, okay, through this hardware. Okay, and then fourth generation we are using right now microprocessor. Simply we call it as chip. Okay, so in this chip we can call it as electronics. Okay, so electronic circuits means we are going to pass the circuits value. Why? To do the operations, that means calculations in our system. So in our system means we should know about this electronics method. So electronic circuits, here I'm going to make all the circuits in a digital manner, not in an analog manner. Okay, so here we can see two types of circuits. One is analog, another one is digital. So analog means we can pass the circuits continuously without interrupt. But digital, we are going to move the values in discrete method. Okay, so discrete method means we take some breaks. Okay, no, we are not going to pass the information continuously. For example, smartphones, laptops, here we can see the digital signals. But when you are hearing radios. Okay, so radio stations, they are passing analog signals only, because it will run continuously 24 hours continuously it will run. So in that department, in that radio department, they will use analog signals, not in a digital signal. But if we take smartphones, we are looking digital signals only. So how it works, and how it works in that computer system, and uh, what are the operations we can do in this electronic devices, let's see. Okay, so here you can see this is the first example for CMOS NAND gate. Okay, so Digital electronics means here we are going to see processors, logic gates, as well as some of the operations. Okay, this that means number systems. Okay, so how we are going to do our calculations and how we can store our data in a digital manner. Okay, so this is for the CMOS NAND gate means complementary oxide semiconductor NAND gate. Okay, so gate means each and every circuit. Okay, so here this is your electronic devices. Okay, so all the electronic devices here we can take our system computer. Okay, so in this computer the motherboard, here I am using microprocessor. So that microprocessor is developed in a digital circuit. Okay, so digital circuit means I am using semiconductor. So semiconductor means here I maintain some gates. Okay, so for example I'm going to pass this value. Digital means zeros and ones. Okay, so zeros for low voltage and 1 is for high voltage. Okay, so 0 low voltage and 1 for high voltage. Okay, so how we can apply this method in this digital electronics means here you can see this example. This is for picture which I have shown for your understanding, that circuits picture. Okay, so circuits picture, here we can take voltage A up to voltage Y. Okay, so I'm going to pass this voltage for 4 terminals. Okay. So terminal 1, terminal 2, terminal 3 and terminal 4. Example, my first value is low. Low means 0. For voltage A value is 0 and voltage B value is 0. Both 0. Okay, so 0. Here you can see, you can write first value is 0 0, next value is 0 1, third value is 1 0 0 0 0 1, fourth 1 0 and last one is 1 1. Okay, so first I'm going to pass this values voltage. Okay, or where I'm going to pass this voltage in the circuit. Okay, so first low means both are 0, that means off position. Okay, so if both values are off means my terminal 1 and 2, that condition is on. Okay, so I open that gate, terminal 1 and terminal 2 is open. What about the terminal 3 and 4? It's opposite. Okay, so if terminal 1 and 2 is open means terminal 4, 3 and 4 is going to close. Okay, that terminal 3 and 4, that voltage has closed. And next, if I pass this value low and high, for voltage A I'm going to pass the value 0 and for B I'm going to pass the value high, that means 0 and 1. Okay, one is off position, another one is on position. So terminal 1 I'm going to get that on position. Okay, and terminal 2 is off position. It's the same different. Terminal 3, so terminal 1 and 3 is on position, 2 and 4 off position. Okay, so that time my voltage, okay, so voltage last, voltage Y will be a value is high voltage, so I can supply high voltage. Okay, next I'm going to pass the value for voltage A is high and voltage B for low value, that means 1 and 0. So I can get 2 and 3 is on position, 1 and 4 is okay, so 1 and 3 is off position, 2 and 4 is on position. So that time also I am going to get high voltage. Okay, and fourth, terminal, if I pass this high voltage, okay, both A and B, I will get terminal 3 and 4 only high voltage. Okay, so remaining voltage is fully off. That time if I pass high value, I will get low voltage. If I pass one is high or another value is low, I can get high voltage. Okay, so if I pass low both are low values, means I can get high values. If I pass one is low or one is high, I can get high voltage. If I pass high voltage, means I can get low voltage. Okay, so this is the circuits method in digital electronics. Next, let us see the number system, how we can store the information, as well as how we can perform the calculations by using of this gates. Okay, and next, so complementary oxide semiconductor. Okay, so semiconductor gates is used to build the NAND gate. NAND gate means not plus AND gate, both combination, not plus AND gate. Okay, so combination of not plus and NAND. Okay, and NOR gate means not plus OR, that is a combination of not plus OR gates, NAND gates. Okay, so in this digital circuits, maximum we are going to see AND or NOT gate. Okay, and then they have similar electrical properties to the CMOS inverter. Okay, because this semiconductor is going to act like a inverter. So what is the use of inverter? If I pass this high voltage circuit, so automatically it converts the low voltage according to my electronic devices. So that is the of inverter. Otherwise, battery charges. If my voltage or current is supply is off, means the inverter is backup. Okay, so it will produce some voltage for my circuit. Okay, so it stores all the information in a battery. Okay, so in this batteries I am going to supply the direct current. Okay, so inverter is going to make a small unit of current for my service, for my home services or home appliances. Okay, so that is the work of inverter, that is backup. Okay, so next here, so noise margin means this is one of the formula for this digital electronics when I pass this high voltage or low voltage in the circuits. Okay, so here I am using some voltage formula. So we can see if I pass this high voltage means 1. Okay, so high voltage volume means noise margin is worst case output. Okay, so we can get that output voltage minimum. If I pass this low voltage, means you can get this maximum. Okay, so if I pass the high voltage, you can get the minimum voltage. If I pass the high circuit, low circuit, you can get the high value voltage. Okay, so that is the output of your circuit when you seeing in the noise margin. Okay, so this is the worst case situation. Okay, so here you can see this, when I pass this low voltage, you can get the maximum voltage. When I pass the high voltage, you can get the low voltage, minimum voltage. Okay, and next, logic families. So what are the families we are going to see here? NMOS, CMOS, TTL and ECL. Okay, so NMOS is used for compact, slow, cheap and absolute. Okay, and then CMOS older families. We can use this series 4. For example, the transistor, capacitor, they will use some diodes, uh, resistors, conductors, everything they will use. Okay, so right now we are using microprocessor, that is small chip. Okay, that is very compact one. So that's the reason we are using this gates. These are this logic families. These are this families of logic, and TTL for 74 series devices. Okay, so this is also available in oxide semiconductor. Okay, and EZL for why we are using this type of logic circuits in our motherboard means high speed but high power consumption. Okay, so that's the reason we are using this ECL circuit. Okay, so digital electronics, we are going to do our operations in a very quick manner, so we have to develop our motherboard circuits with a very high speed power. So high speed power means right now we are using small chip. Chip means microprocessor. Okay, so but previous years we used transistors, vacuum tube, and integrated circuits. Okay, so this is the best example for circuits transformation. Okay, and next let's move on this number system. Here we can use or we can apply operations, logical operations in digital electronics. How we can do? So first concept is number system. Okay, so in this digital electronics we can see three types of number system. One is decimal, hexadecimal, another one is binary. Okay, so decimal, whole numbers from 0 to 9, and hexadecimal 0 to 50. Binary, boolean values, zeros and ones. Only two values we are going to apply this calculation. Okay, so let us see how we can perform this calculation. So in this example they given some summation of this digits. For example, if we take decimal values mean 2 3. Okay, so this is your decimal values. If you are getting this binary value means how we can get this? If I want to convert this decimal value to binary, D to binary means, okay, so the radix base is 2, right? Your base radix should be 2. Okay, so they given some decimal values. I need binary values. How we can calculate or how we can expand? Already they given some value. For example, 20 25. Okay, here you can see. So we can write now the decimal value we are going to expand in this form. Okay, so 20 25. How we can do this? Here binary means we can use this base or radix value is 2. If it is hexadecimal means we can use 16. The radix value is 16. Okay, so now 20 25, this is your decimal value, so the base value is radix is 10. Okay, 2. So here the power we can apply from the rightmost digits. Okay, so first digits I am going to apply, that power is 0, 2 power is 1, and 0 power is 2, and 2 power is 3. Okay, so we are applying this methodology from right to left methodology. Okay, so here you can see 20 25, that power value is 0 1 2 3. Okay, so now we can expand this form into binary method. Okay, so 2 into 2 power 3, because I'm going to convert this value in binary. So that's the reason I'm using this value radix 2 plus next 0 into 2 power 2 plus 2 into 2 power 1 plus 5 into 2 power 0. Okay, so anything power 0 you can get the same answer 0, right? Okay, So you can get this similar answer. 0. 2 power 1 is 2. Okay. So 2 2s are 4. And here 2 powers are 4. But if you multiply with 0, you will get the answer is 0. Right? And next 2 power 3 is 8. So 8 into 2, that value is 16. So now you add this value 16 plus 4, you can get that answer 20. So this is the decimal expand form of this 2025 value. Okay. So like this we are going to see in our digital electronic number system. Okay. So this is for the decimal example. Another example for hexadecimal. Okay. So hexa means here I am going to use 16 digits. Okay. So 0 to 9 numbers and 10 to 15 I am going to use letters. Okay. So let us next. For example, here I give some example 4A D1. Okay. So what is the value of A? 10, 11, 12, 13. Okay. So A, B, C, D. Okay. So this is the value for hexadecimal 13. So now we are going to write this answer. 4, A means 10 and D value is 13. Last value is 1. So this is your value. Okay. 4, 1, 0, 13, 1. Now we are going to calculate this value. Okay. How? Let's see in hexadecimal. So my query is 4A D1. Okay. So here you can get this value 4. If I divide by 2, you can get this value. Remaining 0. So now that value is, you can get, okay, for 4 value is 4 A B 1. Okay. So 4 value is, you can get 1 0. Right? This is your 4 value. Okay, next A value is 10, right? So if I divide by 2, 10, you can get 2 2s are 4, remaining 1 and 1 2s are. The answer is 1010, 4 digits, right? This is your 10 value. And D value 13. 13 you can divide like this. 2 2s are 1. 1101. Okay. So that is your 4 value 100 and 4 value is 100, and for example a value is 1010 and b value is 1101 and one value is 1, right? Yes. 4 a b 1. So how we are going to perform our applications calculations? 4 value is 10, right? A value is 1010 and b value is 1101 and one value is 1. So here I need to get 4 digits. Okay, so first value I am having only 3 digits. So before previously I am going to add in the right side. Okay, so now I got 4 digits, 0. Another remaining a 4 digits, okay, d 4 digits, and last one is only 1 digit. So I need 4 digits. That's the reason I'm going to add 3 bits to the next bits. Okay, so bit means we are going to store some information. Okay, so zeros and ones, boolean values are called bit. Okay, so now the binary value is 0 1 double 0 1 0 1 0 double 1 0 1 triple 0 1. This is your binary value for this 4AD1. So this is your hexadecimal value. Okay, this is your binary value. So like this calculations programs we can perform in the digital electronic circuits. Okay, so this is the methodology for converting hexadecimal to binary. Okay, so next class we can see binary to decimal and octal conversion. Okay, so thank you so much. Bye from Jim.